Okay, assalamualaikum and good day everyone, and today we are going to present a video for our assignment 2. We will require to discover a real world problem from daily life that can be modeled using vector quantities. This does encourage us to go beyond textbook theory and demonstrate how mathematics function as a practical in areas such as navigation, force, and displacement.
In our individual writing assignments, we explore vector concept by identifying suitable real-life situations, calculating the necessary components, illustrating the relationship between vectors, and also presenting our findings in a structured format. In this video, we're going to talk about reflection on the strength and the weakness of our writing, as well as the challenges we face throughout the processes.
In our writing assignment, we aim to demonstrate a clear understanding of vector quantities and their application. We ensure that our explanation were logically organized and systematically presented according to the requirement of the task. Despite our efforts, we acknowledge that there are areas that could be improved in our writing. Through the process, we face certain challenges in ensuring clarity, precision, and depth in our explanation.
This does require careful interpretation of real-life problems and accurate application of vector concept, which demands both conceptual understanding and attention to detail.
Without further ado, let's get into our next session, which is the three of us will presenting the strength and the weakness of our writing assignment. Every movement has a direction, and every direction has a consequence. Even something as simple as crossing river can become complicated when current and wind are involved. That is where vectors concept became important, because they help us understand motion in terms of both magnitude and direction. Hi and good day everyone. My name is HUMAIRA FAUZI and I am from MT1104. And today, I will be presenting my reflection on my algebra assignment for the course Mtes1104, which is algebra. In this presentation, I will discuss the strength and weakness of my PB writing. This reflection is based on my report entitled Application of Vector Concept in a River Crossing Problem with Current and Wind. Through the assignment, I explore how vector quantities can be applied to model real-life situations, particularly when multiple forces act simultaneously and affect displacement. Let's move on to the part 1, which is personal strength of my writing PB. Okay. For further understanding, I will read you the problem statement in my writing PB. A ferry needs to cross a 300-meter wide river from point A on the south bank to point B, directly opposite on the north bank. The river current's flow is at 2.0 meter per second. A steady wind pushes the ferry northeast at 1.0 meter per second at 45 degrees. The ferry can move 3.5 meter per second through still water. The objective is to apply vector quantities for: first is find the heading angle the captain should take to avoid drifting east or west. Second is calculate the time needed to cross the river. The third one is determine the ferry's ground speed and sideways drift if the captain goes straight north without adjusting. All velocities can be treated as vectors, with north as positive y and east as positive x. Now, I would like to begin with the strength of my writing. One of the main strengths is that I clearly introduce the real-life situation before presenting any calculation. I explain the various movements across the river, including the effects of current and wind, as well as the given speeds and direction. This is important because in vector problems, misunderstanding the situation can lead to incorrect results. By explaining the scenario first, I allow the readers to visualize the motion before moving into the mathematical analysis. Another strength of my writing is the organization of the report. I divided the assignment into clear sections, beginning with the introduction and problem statement, followed by the formulation of vector quantities, the calculation process, and finally the conclusion itself. This structured approach helps guide the reader step by step from understanding the situation to obtaining the final results. In addition, I clearly define the coordinate system at the beginning. By setting which direction represent the x-axis and the y-axis, I ensure that consistency throughout the analysis and avoided ambiguity when resolving vector components. I also explained how the wind vector was resolved into horizontal and vertical components, including the reasoning behind the use of sine and cosine. This demonstrates conceptual understanding rather than simply applying formulas. For overall, the strength of my writing lies in its clarity, logical structure, consistent modeling, and systematic presentation of calculation. Next is I'm going to move out to the part 2, which is I'm going to talk about my personal weakness and challenges. However, there are also areas where my writing can be improved. One weakness is that in some parts, I focus more on calculation than on interpreting the result. After obtaining numerical values, I did not always explain clearly what those results mean in practical terms for the movement of the ferry. And for another weakness involves the explanation of angle reference. Although I use the correct trigonometric expression, I do not clearly describe how the angle was measured in relation to the coordinate system, which may cause confusion for some readers. In addition, I sometimes assume that the reader already understood certain concepts. Some equations were presented without detailed verbal justification, which may reduce clarity for readers who are less familiar with vector analysis. When negative values appear in the component equation, I could also have explained their physical meaning more clearly. Lastly, I believe my academic writing style can still be refined, especially in terms of sentence separation and smoothness. In conclusion, this algebra assignment has been a valuable learning experience for me. It allowed me to apply vector concept to a realistic situation involving a ferry affected by current and wind. Through this task, I strengthened my understanding of vector components, vector addition, and the importance of direction in modeling motion. At the same time, I became more aware of areas where I can improve, particularly in interpreting results and enhancing clarity in technical writing. Overall, this assignment has improved my problem-solving skills and deepened my appreciation for how mathematical modeling applies to real-life situations.
Hi, Assalamualaikum warahmatullahi wabarakatuh. First, I would like to introduce myself. My name is SITI HIDAYAH binti ZAINUDDIN, and here is my IC number and email, phone number. My program, my courses is Mtes1104 Algebra. My born date is on 11 February 2006, and here is my guardian's name, and this is guardian's phone number, and my address is Bacok.
Hi, now I would like to explain the problem statement of my project.
In this study, I designed a real-life scenario involving a drone delivery system operating within the college campus. So,
the purpose of this scenario is to demonstrate how vector algebra can be used to model navigation in three-dimensional space. The drone is required to transport important documents from one location to another efficiently and safely. Instead of flying directly in a straight line, the drone must pass through an elevated checkpoint to avoid obstacles such as building and trees. The movement of the drone is represented by the three coordinate points. The first one is point A, which is 120, represent the student's hostel. Point B, which is 569, represent an elevated checkpoint above the academic building. Point C, which is 910, represents the library. When the drone travels from point A to point B and then from B to C, its movement forms two displacement vectors in three-dimensional space, which are vector AB and vector BC. The main problem in this scenario is to model and analyze the drone's movement using vector algebra. Specifically, we want to determine the displacement vectors of each segment, the total distance traveled by the drone, the direction of motion for each path, and the angle between the two flight paths. This problem clearly shows how mathematics, especially vector algebra, can be applied in real-world navigation systems and modern technologies such as autonomous drones.
Here, as you can see, here is my objective of the study. So the first one is determine the displacement vectors from A to B and B to C. Calculate the total distance using vector magnitude. Identify the direction of motion using unit vectors. And the last one is determine the angle between flight path using the dot product.
Finally, the overall objective of this study is to demonstrate that vector algebra is not just theoretical mathematics, but a practical tool used in real-life applications, such as drone navigation, robotics, and spatial planning. Next, I would like to share the strengths I gained while completing this project. One of my strengths is that I was able to connect mathematical theory to a realistic and meaningful situation. This helped me see that mathematics is not just numbers and formulas, but a practical tool used in technology and daily life. Secondly, I successfully understood how displacement vectors, magnitude, unit vectors, and dot product are interconnected. At first, I saw them as separate topics.
So here is the algebraic models and solution. The first one is displacement vectors. Here is my calculations. And this one is distance calculation using magnitude of vectors. And this is the solutions for that. And then the third one is unit vectors for direction of motion. Here is my solutions. And I also write conclusion for each answers. And the last one is angle between the two flat parts using the dot product. So here is the solutions.
Great topics. However, through this project, I realized that each concept supports the other. This interconnected understanding strengthened my conceptual clarity rather than just memorizing formulas. Another strength is that I was able to organize my solution step by step in a systematic and structured manner. This logical flow improved my mathematical communication skills and ensured that my calculations were clear and easy to follow. In addition, I developed better analytical thinking skills. Instead of directly applying formulas, I had to first interpret the situation, translate it into mathematical language, and then choose the correct vector operations. I also improved my confidence in handling three-dimensional vector problems, which initially seemed challenging and complex. Visualizing movement in 3D space was not easy at first. However, through practice, revision, and deeper understanding, I became more comfortable with spatial reasoning and mathematical modeling. Overall, this project strengthened my analytical thinking, improved my conceptual understanding, enhanced my problem-solving skills, and deepened my appreciation of how algebra supports modern technological systems such as drone navigation and autonomous movement. However, I also encountered several weaknesses and challenges during the process of completing this project. Firstly, I initially struggled to visualize vectors in three-dimensional space while I understood the coordinate points mathematically. It was difficult for me to mentally picture how the drone moved upward, forward, and downward between the three locations. And at the beginning, I found it challenging to imagine the orientation and direction changes clearly. This made me realize that understanding vectors is not only about calculation, but also about visualization. Secondly, I found the dot product and angle calculation slightly challenging at the beginning. Although I was familiar with the formula, I did not immediately understand its geometric meaning. Understanding how the dot product relates to the angle between two vectors required deeper conceptual thinking. Understanding how the dot product relates to the angle between two vectors required deeper conceptual thinking. I had to revise to fully grasp why a negative dot product indicates an obtuse angle. This process showed me that memorizing formulas is not enough. Another weakness I faced was simplifying radical expressions when calculating magnitudes. While the steps were straightforward, I had to be very careful with square roots and simplifications to avoid small errors. Even a minor mistake in arithmetic could affect the final answer, especially when calculating the total distance or the angle. In addition, I realized that my problem-solving speed was not very fast when dealing with multi-step calculations. Since this project required several stages, displacement vectors, magnitude, unit vectors, and angle calculation, I had to manage my time carefully. However, despite these weaknesses, they became valuable learning opportunities. By identifying my difficulties, I was able to revise the concept more carefully, seek clarification, and practice additional examples. As a result, my understanding of vector algebra improved significantly. In conclusion, this project allowed me to apply vector algebra in a meaningful, real-life context while also helping me identify my strengths and areas for improvement as a mathematics learner.
Hi everyone,
My name is UMAIRAH binti Cik Bakar. My metric number is P25080329 and I'm from class Mathematics 3 PPISMP 2526.
Today I will present my report on the application of three-dimensional vector algebra in aircraft navigation. In everyday life, traveling from one place to another may seem simple, as we often imagine movement along a flat surface. However, aircraft do not move on a flat route. Instead, they travel through three-dimensional space where direction, altitude, environmental forces such as wind must be considered simultaneously. Because of this complexity, pilots and aviation engineers rely on mathematical tools, especially vectors, to analyze motion and ensure that an aircraft reaches its destination accurately. Vectors are useful because they combine magnitude and direction, allowing us to represent motion, velocity, and displacement clearly in space. Therefore, this report demonstrates how three-dimensional vector can be used to analyze aircraft navigation when wind affects the flight path. In this scenario, an aircraft departs from BHARU airport, which is represented as point K at coordinate 000. The aircraft must reach Shah Alam airport, represented by the vector as 120, 80, 10. This means the aircraft must travel 120 km east, 80 km north, and climb 10 km in altitude. However, the journey is affected by wind, represented by the vector W. This indicates that the wind pushes the aircraft 20 km per hour toward the west and 15 km per hour toward the north. Therefore, the main objective of this study is to determine the displacement vector of the aircraft, the corrected velocity required to calculate the wind, the angle between the wind and the flight path, and the estimated travel time. While all of this will be solved using algebraic vector operation. After that, the dot product was used to calculate the angle between the wind vector and the flight path. Finally, by applying the speed-distance time relationship, the estimated travel time was calculated to be approximately 56 minutes only. Now, we go to the strength and weakness. That's the main focus in my video. Now I will discuss the strength and weakness of using three-dimensional vector algebra in this analysis. Understanding both strength and limitation is important because it helps us evaluate how effective this mathematical model is when applied to real aviation system. For the first strength is accurate representation of 3D motion. The first major strength of using vector algebra is its ability to accurately represent motion in three-dimensional space. Aircraft movement involves three components: horizontal movement in the east-west direction, horizontal movement in the north-south direction, and vertical movement in altitude. By introducing a three-dimensional Cartesian coordinate system, these three directions can be represented clearly as the x, y, and z axis. This allows the aircraft's position to be expressed mathematically as a vector. This vector tells us exactly how far the aircraft must travel in each direction. This representation provides a much more realistic description of aircraft motion compared to traditional two-dimensional distance calculation. According to elementary linear algebra, vectors are fundamental tools used in engineering and physics because they allow spatial relationships to be analyzed mathematically. Therefore, one important strength of this model is that it provides a clear, precise mathematical description of aircraft movement in space. Okay, for the second one of strength is about integration of magnitude and direction. In aviation navigation, knowing only the speed of an aircraft is not enough. Pilot must also know the direction in which the aircraft is traveling. Vector represent this information simultaneously. For example, the displacement vector provide directional information about how the aircraft moves eastward, northward, and upward. When we calculate the magnitude of this vector, we obtain the total spatial distance of 144.5 5, 7. This magnitude represents the true distance traveled in three-dimensional space, combining horizontal and vertical components into a single value. This capability makes vector extremely useful in engineering calculation because they simplify complex spatial problems into manageable mathematical operations. For the third strand of my PV is precise wind correction. One can significantly influence the trajectory of an aircraft, even if the aircraft is directed toward the destination. Strong crosswind may push it away from its intended pace. By representing wind as a vector, we can analyze its influence mathematically. In this study, the wind of vector W show that the wind pushed the aircraft westward and slightly northward. Using vector subtraction, we determine the corrected aircraft velocity need to compensate for this one. In real aviation systems, similar calculations are used in flight management, computer, and navigation systems. For the last one of strand in my PB report is analytical insight through angle measurement, which is the ability to examine directional relationship using the dot product. The dot product allows us to calculate the angle between two vectors, which provide insight into how different forces interact. In this analysis, we calculate the angle between the one vector and the aircraft displacement vector. This means the one is partially opposing the aircraft's intended direction, creating a head-one component. This information is important because it explains why the aircraft must increase its velocity to overcome the opposing one. Therefore, this method provides deeper insight into how environmental factors influence aircraft navigation.
So now we move to the weakness in my PB. There are 4 weaknesses in my PB. That is, assume constant wind, assume straight line motion, ignore aircraft performance limitation, and model does not include acceleration. For the first one, weakness in my PB is the assume constant wind. Despite this advantage, the model also has limitation. The first limitation is that the analysis assumes constant wind condition. In reality, atmospheric conditions are highly dynamic. Wind speed and direction can change due to weather system, temperature difference, and pressure variation. Aircraft may encounter turbulence or sudden wind shift during flight. Because this model assumes a constant wind vector, it simplifies the complex nature of real atmospheric behavior. Another limitation is the assumption that the aircraft travels in a perfect straight line from the departure airport to the destination. In real aviation operation, aircraft rarely fly in perfectly straight paths. Pilots must follow routes determined by air traffic control, aviation regulation, and international flight corridor. In addition, weather conditions may require aircraft to change route during flight. As a result, actual flight paths often involve multiple directional adjustments. Another weakness is that this model does not consider aircraft performance limitation. The calculated velocity required to counteract wind may be mathematically correct, but in real aviation system, aircraft speed is limited by factors such as engine power, aerodynamic drag, fuel consumption, and safety regulation. Therefore, a mathematically ideal solution may not always be physically achievable. Finally, the model assumes that the aircraft travel at constant velocity throughout the journey. In real flight, aircraft motion includes several phases such as takeoff, climbing, cruising, and descending. During these phases, the aircraft speed and altitude continuously change. Therefore, real aircraft motion is more complex and dynamic than the simplified model used in this study.
So now we are going to discuss about improvement in our future learning.
Okay, reflecting this assignment, I realized that it actually gave me many insights about both my strengths and the areas that I still need to improve. In my case, I analyzed the navigation of an aircraft traveling from Kota BHARU to Shah Alam using the three-dimensional vector analysis, while also considering the influence of wind on the aircraft motion. At first, I thought the task would mainly involve equation and calculation, but while working on it, I realized that mathematics is not only about getting the correct answer.
Yes, but also about understanding how the mathematics represents a real situation, right?
Exactly, because in this case, the vector were actually modeling the aircraft movement in real space. So we had to think about the east-west direction, north-south direction, and also the vertical altitude component at the same time.
That's actually quite similar to what we experienced in a very task in my writing assignment. In my report, I analyzed the motion of the ferry crossing a river, where the movement was influenced by both the river current and the wind. So, instead of just looking at one direction, we had to consider several vectors at once and understand how they interacted.
Yes, I remember when we discussed that the ferry wasn't just moving straight forward, but its direction was affected by other forces too.
Exactly, Hidayah. And because of that, we had to resolve the vectors into components before combining them to determine the ferry's actual motion.
For me, my task was slightly different because I used vector concepts to model the movement of drone delivering the document across the campus. But even though the scenario was different, I realized we were still applying similar vector concepts like displacement vectors, magnitude, and dot to represent the movement in three-dimensional space.
Yes, that is interesting actually. Even though our contexts are different, aircraft, ferry, and drone, we are still using the same mathematical ideas.
That's true, HUMAIRA. It shows how versatile vectors concepts are.
Myra, however, while completing the assignment, I realized that one area I still need to improve is my ability to visualize three-dimensional relationship more clearly. Even though I could calculate the displacement vector and its magnitude, understanding how those three dimensions interact in space sometimes require deeper thinking.
Yes, I can relate to that. Even in my drone model, I sometimes had to imagine how the drone moves from one point to another in space.
Same here. When dealing with multiple vectors at once, it's easy to get confused if we cannot visualize the directions clearly.
Exactly. So, in the future, I think practicing more problem involving three-dimensional vector and spatial representation will help strengthen my understanding.
For me, one area that I want to improve is my confidence in solving multiple vectors problem. Because in the first scenario in my writing PPT, we had to analyze several vectors simultaneously: the ferry propulsion, the river current, and also the wind. So, solving the problem required careful analysis and a clear understanding of how these vectors combine.
Yes, those types of problems definitely require patience and step-by-step reasoning. In my case, besides improving my understanding of vector calculations, I also realized that I need to improve my ability to explain mathematical ideas more clearly, because during the presentation, it's not enough for us to simply show the calculations.
Yes, we also need to explain the reasoning behind each step, right?
Yes, Myra. So that the audience can understand the mathematical process, not just the final answer only.
That is especially important since we are preparing to become future mathematics educators. Being able to explain complex mathematical ideas in a clear way will help students develop a better understanding of the concept.
Another thing that I found meaningful from this assignment is seeing how mathematical modeling can explain a real-life situation. Before this, vectors sometimes felt quite abstract, but through this scenario, we could see how they can be used to analyze motion and make decisions.
Yes, and I think that's why I'm also interested in exploring more and more applications of vectors in modern technologies such as navigation systems, robotics, and road movements. Seeing how mathematics is used in the real world, technology makes the learning process more meaningful.
I agree with you, Hidayah. When we connect mathematics with real-life application, it helps us understand why these concepts are important.
And it also reminds us that everyone's learning experience can be different. Each student may face different challenges depending on their understanding and learning strategies.
So, Myra and Humain, through this assignment, we realized that improving our understanding of this requires continuous practice, stronger visualization skills, and clearer communication of mathematical ideas. By exploring more and more real-world applications and engaging in discussion like this, we believe we can continue strengthening our mathematical understanding in the future. See you soon. Bye. Bye.
Oh my, she's a long way from suburban towns, straight to the city.